Hello Math Analysis students. In this video we are going to cover page 2 of the Unit 1 review. Okay, so first we have factoring. Factoring is breaking up a polynomial into the smaller expressions that multiply together to give that trinomial. And there's a lot of different ways that you might factor. Personally, myself, I have learned the guess and check method. That is what I tend to do. But there is also a method called X factoring, which I am going to also do on this one after I first do my guessing and checking way. Okay, first we have this expression right here, 3x squared plus 16x plus 5. So it is a trinomial, and it is going to factor into two binomials. All of these are going to factor into two binomials. And our first expression, our first term is 3x squared. So that means our first term in each of the binomials has to multiply together to be 3x squared. So that has to be 3x times x. That's the only way you can take two terms to multiply together and get x squared is 3x and x. Our last terms have to multiply together to be 5. Now, because this expression does not have a leading coefficient of 1, we're not looking for things that just multiply to be this last number and add it to be this middle number. Because whatever we put in this spot right here, it is going to have to be multiplied by this 3x. So we have to consider that when we are looking at our different choices. In order to multiply together to be 5, though, the only numbers that multiply together to be 5 are 1 and 5. So for me, guessing and checking, I plug them in and see which one's going to work. Now, I'm going to try one first. This is not the right answer. If I put a 1 here and a 5 here, since everything is positive, I'm going to have positive and positive, and then I test this out to see if this is right. When I multiply this, I'm going to get 3x squared, and I will get my outer terms give me 3x, and my inner terms give me 5x, and my last terms give me 1. When I add these up, here I get an 8x, which is not what I need. So that means this factoring is not correct. You should always be able to tell if your factoring is correct or not by checking it. So I tried a 1 here and a 5 here. That didn't work. I guessed it. I checked it. It didn't. Now I'm going to guess something different. What if I put the 5 here and the 1 here? When I multiply this, the first terms give me 3x squared, outer terms give me 5x, inner terms, 5 times 3 gives me 15x, inner terms is 1x, and then the last terms give me 5, and here when I multiply these, when I combine like terms, I get 3x squared plus 16x plus 5, which is exactly what we were trying to get. What does that mean? This factoring pattern right here is correct. I guessed, didn't work. I guessed something different. It worked. For our next factoring problem, this one is just a binomial. This one is a difference of squares. 4 is a square, a squared is a square, and it's a minus sign, and 81 is a square. So this factors into, this is one of our nice factoring patterns, it factors into two terms that are the same except for one's positive and one's negative, and those are conjugates of each other. So this is the square of 2a, so we have 2a in the first one, and 81 is the square of 9, so we have a plus 9 and a minus 9. When you multiply those out, you do indeed get 4a squared. Our outer terms and our inner terms are the same thing, but one's positive and one's negative, so they cancel out, and we get negative 81. And our last set right over here, 7x squared minus 26x minus 8, going to have two binomials. In order to multiply together to get 7x squared, we have to have 7x times an x, and our last factors have to multiply to be negative 8. So there's only a couple of different ways that could work. We could be looking at a 1 and an 8, or a 2 and a 4. Try some different things, see what works. In the end, what works is a 7x plus 2 and an x minus 4. How does that work? When we multiply it back out, we get 7x squared, and then 7x times negative 4 is negative 28x. Then positive 2 times x is plus 2x, and positive 2 times negative 4 makes a negative 8. When we combine this right here, we get negative 26x, which is what we were trying to get, which is what the original expression was. And so that means this expression is, in fact, correct. Okay, now I know a lot of you guys use X factoring, so I am going to also do a bit where I factor number 13 and number 15 by X factoring. If you don't need to see X factoring, feel free to fast forward through this part of the video. Okay, sometimes I struggle with X factoring because it's not my go-to method, but I've got it for this one. So we're going to do this 3x squared plus 16x plus 5 was our problem. And if we do an x method of factoring, then up here we multiply our first and our last term. 3x squared times 5 gives us a 15x squared. And the middle term, the 16x, positive 16x, goes down here. And here we are looking for things that will multiply together to give us 15x squared that will add up to be 16x. And that is going to be a 15x plus a 1x. Now, for x factoring, what we end up doing over here is replacing this middle term with these middle terms here. And so we have 3x squared plus the 15x plus 1x plus 5. And then we factor this by grouping. We'll factor this part and factor this part and see what they have in common. So this first set has in common a 3x. We pull that out and we're left with an x plus 5. What do these last two terms have in common? They really don't have anything in common besides a 1. But they do have a common factor of 1. And if we pull out that 1, we've still got an x plus 5. Now here, these two expressions match. That's good. That's going to be one of our factors, and the other factor is going to be what we pulled out. And so our answer for this ends up being 3x plus 1 times x plus 5. And that is how we do this problem by x factoring. The next problem on the page, number 14, was a difference of squares. I don't think that one really works nicely for x factoring, but I am going to do this last problem right here. Number 15, which was 7x squared minus 26x minus 8. So when we x factor, we multiply this first term and this last term. 7x squared minus 8 gives us a 56x squared. We multiply them, that actually gives us a negative 56x squared, and they add up to be a negative 26x. Things that multiply together to be negative 56x squared. We could have a 1 and a 56, a 2 and a 28, or 7 and 8. So it looks like 28 and 2. In order to add up to be a negative 26x, we could have a negative 28x and a positive 2x. So then this gets replaced by these two terms right here. We have 7x squared minus 28x plus 2x minus 8. And then we factor by grouping. This first set has a common factor of 7x. We factor it out and we have an x minus 4. These last ones have a common factor of 2. We factor it out, we have an x minus 4. And then we have this common factor right here, x minus 4. And our other factor is going to be the things that we pulled out, this 7x plus 2. And so our factored result is 7x plus 2 times x minus 4. And you will know if you're right because you can distribute that out and check to make sure that you are right. When you multiply these out, you get 7x squared, and you get a negative 28x and a positive 2x minus 8. And these terms combine to give you that negative 26x, which is what we started with in the beginning. And so that's how we check this, and we know that it's right. And so our answer, let me erase that because I don't want it to look like that's the answer. Our answer is the binomial 7x plus 2 times the binomial x minus 4. Okay, now, moving away from the x factoring there. Now we're going to get to this function over here. It is a rational function. We have x squared plus 2x minus 3 over x squared plus 3x minus 4. So we want to write this, first of all, in factored form. Okay, whatever method you use to factor, guess and check, X, use a box, use some type of factoring method. Since these expressions just have a leading coefficient of 1, that actually makes them a lot nicer, because here we are really just looking for the things that multiply together to be this last number and add up to be this middle number. So for our top function, our top expression, we're going to have an x, and we're looking for numbers that multiply to be -3 and add up to be +2. And the only combination of numbers that multiply to be -3 and add up to be +2 is +3 and a -1. Check your work, make sure that you're right. Same process for the bottom. In order for our first term to be an x squared, we've got to have an x and an x. We're looking for numbers that multiply to be a -4 and add up to be a +3. The only numbers that multiply to be -4 and add up to be +3 are a +4 and a -1. So here is our factored form, and we do have a common factor right here. This x minus 1 would cancel out. I'm going to leave this right here though, because when we talk about the wholes of this function, we need to be able to see that. Number 17, list each point of discontinuity and state if it is a whole or a vertical asymptote. Okay, so that comes from the factored form. First thing we look for is wholes by looking at our common factors that cancel out. So we do in fact have a whole because we have a factor that canceled out. And that whole is going to be at, take this value, set it equal to 0. At x minus 1 equals 0, so that gives us x equals 1. Very good, except that a whole has a very specific point. It is a coordinate. It has an x value and it has a y value. So we have found the x value. Now we need to find the y value that goes with this x value. How do we find that y value? We take this x value, x equals 1, and plug it into our simplified form. So y equals, we plug in 1, that gives us a 1 plus 3 over a 1 plus 4. 1 plus 3 is 4, 1 plus 4 is 5. Our y coordinate is 4/5. So the whole is at the specific point where x is 1 and y is 4/5. In addition to this, we also have another factor over here, this x plus 4, so we have a vertical asymptote. We take this factor, x plus 4, set it equal to 0, and we solve, and we get x equals -4. We have a vertical asymptote at x equals -4. Not just the value -4, but x equals -4, because this represents a vertical line. A line has an equation, and this one is x equals -4. For number 18, we're asked to identify the horizontal asymptote. And the easiest way for us to do this is to look at the original function, actually. For horizontal asymptote, we're comparing the degree of the numerator and the degree of the denominator. In this case, both of them have a degree of 2, so they're the same. We would be looking at Bobo, Botan, or same. Bobo is if it's bigger on the bottom, then 0 is the asymptote. Botan, if it's bigger on top, there is no asymptote. But if those degrees are the same, then we simplify. What do we simplify? We simplify the leading coefficients. This is 1 and 1. When we simplify that, we get 1. Our horizontal asymptote is going to be at 1, but not just the number 1. It's a line, and lines have equations, and a horizontal line has the equation y equals, the specific one is y equals 1. State the y-intercept. Y-intercept is where it crosses the y-axis. And how do we find that? By plugging in 0 in place of x. Our easiest way to do that is going to be by plugging into our original expression. If we plug in 0 into our original expression, then we're going to end up getting -3 over -4. A negative divided by a negative is a positive, and so it is a positive 3/4. The specific coordinate, we plugged in 0 for x, and we got out 3/4 for y, so our coordinate is 0, 3/4. Now, let's look at the domain. The domain is impacted by wholes and vertical asymptotes. So wherever we have a hole or wherever we have a vertical asymptote, there's going to be an issue with our domain, and we're going to have to jump over something and have a couple parts that are union together. Now, we had a hole right here at the x value of x equals 1, and we had a vertical asymptote at x equals -4. So this means that x cannot be -4 and x cannot be 1. So when we write that in interval notation, it's how we express everything that is not those numbers. Everything from -infinity up to -4 is good, but then at that point we have that vertical asymptote, we have to jump over it. So that's union with everything from -4 to 1. And 1 is where we have that hole in our graph, and then we union that with, we're good from there on out, from 1 up to infinity. If you were looking at a graph of this, if you enter this into Desmos, you will be able to see the vertical asymptotes. You will only be able to find the hole if you look for it or if you know how to do the algebra. So if you're relying on Desmos for this, you are going to miss that hole and you're going to miss part of the domain restrictions. For number 21, state the range. This is impacted by hole and horizontal asymptote. So here we know that we had a hole at the value y equals 4. The specific y value was at 4/5. So we know that y cannot be 4/5. I'm sorry, I didn't mean to make that a negative right there. That should just be 4/5. And also by the horizontal asymptote. The asymptote is 1, so when we're describing our range, y cannot be -1. When we write this in interval notation, we're good from -infinity up to our first value here that we would come to on, sorry, I don't know why I keep writing -1s. I'm sorry, that should be a positive one right there. I don't know why I just said -1, and I apologize for that. From -infinity up to, we come to this hole right here, which is at 4/5. And then we jump over that hole, and then everything else is good from 4/5 up to 1. But then we have that horizontal asymptote. And then we jump over that horizontal asymptote, and everything is good from there on out, from 1 on up to infinity. All right, for our next part, we're going to consider the functions f of x equals x squared minus 2 and g of x equals 3x plus 4. And we're asked to evaluate each of these things. So we have two functions, f and g, and we need to plug this expression into the appropriate function. Number 22, if we're evaluating f of 4a, that means we're going to look at the f function right here, which is x squared minus 2. But we're going to replace the x with whatever it is the f of, that's what we're trying to find. So in this case, we would take our expression, which is x squared minus 2, but we're replacing the x with 4a. And when we simplify this, 4a squared, 4a times 4a is 16a squared minus 2. These are not like terms, so there's nothing else we can do there. For our next problem, number 23, this is g of 3a plus 2. So we're going to plug into the g function. Not the same x function, f function, but the g function. G function is 3x plus 4. But we're going to replace x with this expression. So we will write that g of 3a plus 2 is 3 times, but instead of x, we're going to replace it with something. X plus 4. We're replacing the x with 3a plus 2. We distribute. We get 9a plus 6 plus this 4 right here. And when we combine our like terms, we get 9a plus 10. Okay, our next function is f of a plus b. So we're going to use the f function, which is x squared minus 2. But instead of x, we're going to replace it with a plus b. This is where students get messed up on this all the time, so I'm going to write out everything right here. When you do a plus b, the quantity squared. Squared means times itself, so it's a plus b times a plus b. When you multiply a times a, you get a squared, and a times b is ab, and b times a is ba, which is the same thing as ab, and b times b is b squared. And we combine our like terms right here, and we get a squared plus 2ab plus b squared minus 2. There are no more like terms, so this is our expression. For number 25, it's f of a plus b minus f of a. So f of a plus b, hey, we already found that over here. That is a squared plus 2ab plus b squared minus 2. But then we're going to subtract f of a. And f of a, if you remember going back to our function, is a squared minus 2. Don't forget, though, that you're subtracting this entire expression. This is minus, and you've got to put parentheses around your expression for f of a, which is a squared minus 2. And when we evaluate this, when we simplify, we'll still have that a squared plus 2ab plus b squared minus 2. But then we distribute this minus to the a squared, we get minus a squared. And then this minus a negative 2 becomes a positive 2. Then we look at what can cancel. We have an a squared minus a squared, and we have a negative 2 and a positive 2. And so our simplified answer for this is just 2ab plus b squared. And there we go. That was page 2 of the review sheet.